Alrighty, we're on kind of the second of three lectures on dynamic memory. Although anywhere we use the new and the delete, we are kind of dealing with dynamic memory management. But this is kind of our, big focus on that stuff. Announcements today, same as last time. So thanks to everybody for pushing to get stuff in. On Tuesday, I'll try to get that graded maybe tomorrow, Saturday at the latest. And so I'll kind of hand out a couple extra points on that for folks who do get that in early or did get it in early. And then you have, of course, until Tuesday to get 4 done. And then 5's coming up pretty quick. So our labs today, this week in general, will help your understanding for homework 5. And I'll be pretty flexible with those over the weekend. So if you can get those in over the weekend, I'll grade those things. I know everybody's got a lot going on. And then we got about a week after that until quiz 5 and homework 5. So hang in there on that. We're going to go into homework 5 today. So I think after today, most of you will have enough of what you need to know to go after homework 5 if you want. So I know that's a lot of work if you're still finishing 4, but most of what we covered today is what you need to really just kind of go all the way on homework 5. And there's some big hints in our lecture today. So even if you come back, let's say next weekend, remember this lecture 18. It's got all of the little hints and things in it for homework 5. Should make things a little easier for you. And the 9 is always out there. It's just an emergency escape valve if you need an extra homework. So key things, we talked last time about the difference between automatic memory, which is anytime we have a variable with a name, right? And those variables, other than global variables, exist inside of a pair of curly braces. And so that's the lifetime of that variable. Once we get past a function scope or a while or for loop scope, any named variable that was created inside of that scope goes away. In the sense, it gets off the stack. So that's why we call it automatic. And so even things like arrays come and go automatically when they have a name. So that's a big clue. If you have a new, then the thing that we're pointing to is what's dynamic. The thing that's holding on to the pointer may or may not be dynamic. It depends. But in this case, num pointer is automatic. The new part is a little chunk of memory that we're holding on to with the pointer. So that's sort of a hybrid situation there in those two cases. But here, of course, this is an array. Char PTR is a pointer to the first character in 10 contiguous characters in dynamic memory. So we call that a char pointer, but it really is the same thing as an array for most purposes. Okay, so the way memory is laid out in C++ is simply that for an array, which is kind of nice. And then we'll cover static here in the next couple weeks. But this is really the automatic side of that, and that's the dynamic side of that. Okay. And as we'll see with, and we did with the triangular matrix in lab 17 and more today, we're going to start moving more and more of our data structure kind of pointers and stuff over onto the heap. So that basically all we're really holding on to is like the tip of the iceberg with one little pointer that we can use to find our way through all sorts of exotic data structures. So again, if you want to get a little bit ahead of the game on quizzes and the final exam, this will be a handful of questions in the end. So you might want to take a look at this in your spare time, maybe install the Quizlet app on your phone. You do not need to join the class. It should be open to the public. But if it's not, just let me know and I'll try to figure that out for you. So here, of course, since we have a new something, right? In this case, we're treating a fundamental data type as almost like a constructor. This is like a little hidden feature. So we're saying, give me a character and initialize it to the letter X. So just by saying delete C, I'm saying delete what C is pointing to, which is this little chunk of memory that holds that character X. So that's an okay answer for that particular question. I won't go into all these, but last time we said there's kind of 4 fundamental ways to organize the beginnings of our data structures. We can hold values in our array, we can hold pointers in our array, or we can hold entire instances in our array, or even pointers to entire instances. So this is what homework 5 is going to look like, and we'll talk about that here in just a second. Okay, but the advantage of kind of having pointers is we can have somebody else pointing to that same instance right there. So multiple people can be referring to one copy of something in memory by using pointers. Where over here, we've just got our kind of instance of something stored inside of an array. And if we want to refer to that, we need to maybe point to those, right? So we don't have multiple copies of, for example, your record in a database, because that opens the door to accidentally having two versions of you, right? One that has different classes than somebody else. And we don't want to have that kind of stuff inside of memory. So remember that we're just holding on to a pointer here, and that pointer is pointing to an integer, or this pointer is pointing to a pointer. So that's where we end up with a double pointer. So if my array is pointing to the first item in an array, and that item happens to be a pointer, that's why my array has to be a double pointer. It's a pointer to a pointer, which will eventually be pointing maybe to an integer, okay? So we often get confused about why is it double versus single? Well, here my array is a pointer to an instance. Here my array is a pointer to an instance, okay? So it's kind of a rite of passage in C++ once you finally feel more comfortable with that. Don't feel badly if you feel a little queasy, because those things are definitely kind of one of the more complicated kinds of code to read, okay? So that's our kind of main approaches and some of the key kind of differences between them. We'll see those again. So we're going to talk about our jigsaw puzzle today. I like this homework assignment a lot because it's a lot like real world code. You get a data file, you got to figure out how to it's like pouring water on one of those dehydrated sponges. You're like taking the data and turning it into a structure in memory, and then you do something useful, and then you maybe write that structure back out to a file again. And that pattern exists in a lot of places. I often use video games as an example, but a web page is that example, right? There's layers of Photoshop. If you've ever used a painting program where you have layers that are built on top of layers of different edits, all of these different programs have to reconstitute some boring kind of data. So homework 5 is just the beginning of that kind of example. So we're going to talk about constructors again today. We'll review that a little bit. And more importantly, now that we have a reason to use our destructor, we will learn how to use a destructor to clean up the mess that gets created when we dynamically allocate memory in our constructor. So we finally have a real purpose for using a destructor, and that's to delete anything that was created in our constructor, okay? And then we'll just look at a few more examples of two-dimensional arrays that should get us lots of examples to help us with our homework 5. And that'll lead us to a subject we may have time to talk about, but it's one that we'll definitely cover by Tuesday, and that is the difference between a deep copy and a shallow copy of a really complicated data structure. So this is something that usually leads to some pretty nasty bugs when people are writing complicated code for the first time. If I want to make a copy of our try matrix that we created in lab 17, how am I going to go about doing that? That's kind of a not a trivial thing. We don't want to just copy the pointer, right? We want to make a duplicate of our triangular matrix. So that is the difference between a shallow and a deep copy, and we'll try to cover that if we have time, but that might end up being pushed out until Tuesday. Okay, so that's what we got on tap. Let's take a look at homework 5, which is coming up in just about a week and a half. So the idea is, think of a real jigsaw puzzle. We got a box with some pieces, and they're all in random order. And we want to just pull all the pieces out and kind of line them up on the table before we try to put them into the puzzle. So we need to figure out how to read from the file. And so our file format, and this is our specific file format, and there could be different ways to do this, but what I decided is to start out by telling you how many pieces there are in the puzzle. So there's 1,218 pieces in this puzzle, and each row is a piece of the puzzle. And the first number is an ASCII ID, okay? So the kind of puzzle we're making is one of those character art puzzles, okay? And so we're going to need to read 3 integer values from every row, the first one being what characters should this be? And the other one is going to be a zero-based row and column number where it fits in our puzzle. Okay. So when we talk about laying these pieces on the table, what we're going to do is have an array of pointers. So that's 1,218 positions in our array. And each pointer is going to point to an instance of, we're going to just call it a token, but it's really a puzzle piece. Okay. So each puzzle piece knows what its ID is, and it also knows where it belongs in a puzzle that starts from row 0 and goes up to some number of rows, and column 0 and goes up to some number of columns. Okay. But we're not going to tell you ahead of time how big the puzzle is. So you don't know how many rows and columns until you've read all the pieces. So it's not like you can just go ahead and create a grid and start plugging them in. You got to read all the pieces, kind of figure out what's the biggest row number in there, and only then can you create your two-dimensional grid and start plugging the pieces in. Okay. So we're going to have both a pieces array that's holding all of the pieces on our table, and then finally our goal is to fill this thing up with pointers. But we don't want copies of the pieces. We want to just copy pointers to the appropriate piece into this two-dimensional grid of pointers. So our grid is not going to be a two-dimensional grid of tokens. It's going to be a two-dimensional grid of pointers that points to a unique puzzle piece. So we'll never have a copy of a puzzle piece more than one time. It's just that we have it in our kind of global list of all puzzle pieces, and then we'll have it plugged in eventually into the correct location. Okay. So we'll talk about how we actually do that. But the two things that we're going to do is we're going to print out every puzzle piece. That's the first part. And then we're going to print out our picture. And if we get our picture right, it's going to look like something interesting. So I've kind of taken some online open source art, and I've got a different picture for you in your puzzle. So that one's just a little surprise for when you get your puzzle working. You'll kind of know it if you get it right because you'll recognize what it is. But that's kind of the little reward at the end of all that. And then the important part, we'll talk about this today, is now we want to delete all of the new stuff that we created. So we're going to have one big jigsaw class that manages all of this stuff, right? So we're going to have one instance of one class that's got all of these data structures in it. And we want that thing to clean itself up in a very clean and intelligent way. So we're going to learn how to use our destructors today to get rid of all of that stuff that we create after we're actually done with it. Okay. So that's kind of high level. Okay, so we're going to dig into this. And remember a few things. The blank space there is really just a pointer to a character that is a blank character, ASCII code 32. So if you see a lot of 32s in your data file, that means there's a lot of blank spaces. And that's not a surprise because most pictures have a lot of blank space in them. Okay. So that's just, if your picture is all jumbled, maybe there's something wrong with your blank spaces there. But let's take a closer look at our data file. So puzzle input basic.txt. So this homework assignment, you're going to have to use Program IZ Pro or Replit since we have to work with data file inputs here. So unfortunately, we can't get by without the Pro. So those of you who still need Pro, let me know. But we got this 1,200 and some pieces here. That means you're going to have 1,218 lines after that first line. So your whole file should be 1,219 lines long, okay, if we look at the line numbers in there, okay? And so there's our puzzle piece. And the nice thing in C++ is if you take an integer and you shove it into a character variable, it will automatically become that character. So you don't have to convert it over. You just, in C++, you can just shove it in to a character variable and it will become the appropriate character. In that case, 32 being the space character, okay? So 21 is the zero-based row, okay? So, and 1 is the zero-based column. So if I have, and this is, I guarantee you, many of us are going to have a crashing program because of this. If I read row number 37, that means I have 38 rows at least, right? But if that's the biggest number of a row number I ever encounter while reading my puzzle pieces, we know that our puzzle has 38 rows, okay? A lot of us are going to put 37 as the number of rows in our grid, and our code is going to be unstable and crash at some point, and it's a hard to find bug. So keep that in mind. All of our row numbers are 0 based. So you're going to need to do a little adjustment on that. Same for column numbers, of course. If we find the biggest column is 40 while we're reading our puzzle, then that means we have 41 columns in our grid, okay? So those are kind of the gotchas there, right? And of course, all of our rows and columns can start at 0, okay? So let's take a look at the token class. So this is actually written for you. So every token has a letter, and then it knows where it belongs in the puzzle. Its row and column number, okay? So once you read one row of data from the file, you should instantly create one of these, and all the code for this is written for you. You just really need to call the constructor on the token, and it will create that for you, okay? So inside of our puzzle class, we're going to have an array of pointers, and we'll have a grid of pointers like we saw on the previous page, and they will each be pointing to this instance of the token, okay? And we'll see more about that in just a minute, okay? So, but that's our token class. Then we have our puzzle class. It's our only other class. So this is all we need in main, right? So we have this null pointer, okay? So it's not pointing to an instance yet, but now we say my puzzle equals new puzzle, and we give it some file name. So your constructor for your puzzle class, so you're going to have to write this, is going to go open the file, read the file, create the dynamic array of pointers, all of that stuff, right? For the list of pointers. So it's going to do this, going to create that. It's going to have this in the instance of the puzzle class, but the only thing the constructor is going to do is do this stuff over here on the right side, okay? So pieces is a data member inside of the puzzle class. You're going to need to create a dynamically allocated array based on the first line in the file. How many pointers do I need? 1,218. And then you will slowly build up this list, okay? Now we will have a grid pointer over here. We're going to talk about that in a second. But your constructor's job is just to create this part right here. We'll do this with a separate method in our puzzle class, okay? So a lot of people try to do both of these things at the same time. Just kind of go easy on yourself. Do the constructor first and just load up the puzzle array, or the pieces array rather, right? And then we'll come back and deal with the rest of that stuff later on, okay? So that's kind of step one. And notice that we have a piece count data member, a pieces data member, a row count, and a call count. So your constructor is going to need to set this and create the pointer to this, which will in turn be pointing to all that stuff, okay? You clear away all those scribbles. So that's all part of your constructor's job. And you're going to be doing that inside of the puzzle class. So you can just refer to these things by name: pieces, piece count, row count, etc. inside of your constructor, okay? Now over here, we're going to do this thing over here inside of a separate method. But what we're going to be doing is creating a dynamically allocated 2D array. So it's kind of like Lab 17, but easier, because instead of having a triangular matrix, it's just a regular square one. So you shouldn't be too thrown by that. But that's the job of our load grid method. So, but now the dreaded triple pointer. So our grid is a triple pointer to a token. What does that even mean? So let's look at that real quick. So we want to have rows, and each of those rows are pointers. So the outer grid is a pointer to a pointer to a pointer, okay? So grid is going to point to some structure, which in turn is going to have array positions that are going to point to other structures. And each of those are going to point to ultimately our token piece. Okay. So that's where our third pointer comes from. And we'll see that in a picture here in just a second. But at any time after you call your load grid, you should be able to get a pointer to any puzzle piece at some number, row, column, 0, 0, 0, 0, 1, etc. Okay. So this gives us a pointer, not an actual instance. So we have to follow that pointer to the instance. Okay. So let me see if I can fill in a little bit more here without scribbles, right? So initially we've got all these null pointers, right? And then we're going to kind of build up, all of the, basically the empty space. And then we can go through and hook up all of the individual puzzle pieces, right? Hook all those pointers up. But we will need to allocate that first. And we'll go through lots of examples of that, okay? So here's our array of pieces, right? Pieces pointers. Each one points to some token over here, okay? And then we will say, okay, now I need to allocate all the necessary rows of pointers. And now I just go through and hook them up, right? So grid, let's say grid 0, 0. I look at this and I say, well, who goes here? I'm going to have to find the piece that's at 0, 0. Now, these things are not going to be in nice, even order for you. They're going to be pretty random. So the reality is you're going to be hooking up pointers in all sorts of crazy orders, right? So if you look at the first piece, it might be over here. The second piece might be over here. So you're going to need to be wiring these things up by looping through these positions and figuring out where each piece needs to be plugged in over here, okay? We can't go through these, and otherwise we'd have an n squared search through all of these trying to find the pieces, right? And so for those of you who took Comp 220, probably realize that's not a really great strategy, okay? So we'll see that code here in a second. But the key point is there's only one copy of each token piece, and it's going to be pointed to by two different locations at every time, okay? So let's take a look at our puzzle.h to sort of bring this into focus in terms of the code. So there's our prototype for our constructor that you'll need to write. Obviously, we're just given a name. So that's the file name we got to open. And then we have a method for printing out the pieces once we've actually loaded them in with our constructor. And then again, this is for setting up the grid, right? The pieces get set up by our constructor. So this happens a little bit later on, okay? And then we have our print grid. That's for printing the actual final puzzle, which should look like an actual picture. And then we'll have our destructor, which we're going to talk about for cleaning up all of the allocations that happen here have to be deleted over here. So it's like creation and destruction. Okay, so that's the first time we'll be doing that. Okay, so there's our piece count, row count, and call count, all set by the constructor. Okay, so those things have to be initialized by the constructor. If you get this wrong, your whole program is going to be pretty destabilized. Okay, so there's our pointer to an array of pointers which point to tokens, right? So pointer to tokens. Okay, so that's our double. And our grid, again, is a pointer to a pointer to a pointer to a token. Okay? Don't worry if you don't get that the first time. It's kind of like a bad joke, but it's kind of important to slowly be able to decode that in your head, okay? So let's take a look at what happens in main. That just might kind of bring things a little more into focus. So if I say puzzle star, that means this variable is a pointer to something we're creating over on the heap. So this chunk of memory over here is a puzzle, okay? And this is just a pointer to that instance of the puzzle class. And as we saw previously, the puzzle class is going to have an array of pieces pointers, and it's going to have a grid, and then those are going to be, so that whole thing is held onto by this one pointer over here, okay? And so after I call my constructor, I should be able to immediately print the pieces. So if you can't do this part, you should not go on. I mean, if this isn't working, don't go on to the load grid step, right? Because that means something's not right, okay? But if that is right, then go ahead and call the load grid method from main, okay? And that should hook up all of these pointers. So like this gets pointing over there, this points over there, however all that stuff links up. And then the final bit, or almost final, is printing the grid. So that should make your cool looking picture. And then deleting what this points to, right? So by saying, hey, delete where that points to, we want to trigger a cascading automatic delete of all of this mess that we created in our constructor, okay? So that is our destructor's job, and we'll look at that here today. But if you do all that properly, you'll get no crashes, you'll have a nice picture, and you should be able to see all the puzzle pieces. If you don't see the word done printed out, that means your destructor crashed, okay? And you never really made it out of the destructor. So that's something I usually send back to a few people. I'll be like, hey, looks like your destructor's crashing. So look for that done. That's your clue that you got all the way to the end and things are actually okay, especially if you saw your picture and it looks like a good picture. Okay? So high-level challenges. We're not allowed to use vectors or anything for this one. We're going to do it all with the arrays so that we learn dynamic memory management and pointers. But without a doubt, containers like vector would make things so much easier, okay? But we're going to learn the old-fashioned way. Our pieces are not in any order, so of course we can't just plug them in right away. We got to load them all up first. And I have seen some very clever ways around this problem, so I'm plugging these holes. You may not read the input file more than once. So some people scan the input file, collect some information, and then go back and take a shortcut. So I'm going to ask you not to do that so that we kind of do it the tougher way. And then just keep track of your dimensions, right? So you keep track of, how many rows do you need and how many columns did you need, okay? And then we'll eventually create the grid after that, okay? So remember that one, you should be just fine. Now, couple steps real quick, and we'll go through a couple examples of this, but we're going to dynamically allocate an array of pointers to token pointers. So this is kind of like marionettes, right? So that's us saying grid equals new token double star row count. So if I want to have this many rows in my grid, I want a pointer to a token pointer. I mean, I want that many in that row, okay? So you can think of it like that, right? So it's like a little lookup system on the side where each one of these is going to point to a row of pointers, okay? So for each row, and we kind of did this in lab 17, except we didn't have the triple pointer. We were pretty close. So here is me creating my first row with this many columns of pointers, okay? I still haven't called a constructor yet for any of the tokens. These are just pointers, okay? So now I have this monstrous two-dimensional collection of pointers that I can access from any one of these pointers, okay? So the good news is now when I want to access that thing, I really can just treat it like a two-dimensional array. The first number refers to the row, and then the second number moves me along that row. So if I chose, 0, 1, 2, 3, right? Square bracket 3 gets me to here, and the second pair of square brackets determines which pointer I'm jumping to, okay? So we can just treat it like a regular array, but take a look at what we're going to do. We're going to say, hey, for some piece I, the row number gets me to the proper row in this structure. And for the same piece, column gets me to the proper column. So if I steal the pointer from that, remember this is the grid here that we're working on, and I just say, hey, I'll take that and I will store that in this grid at that location. And now this is pointing to the same puzzle piece, right? That would be pointed to by pieces of I, okay? So this is the magic piece of code here that is not obvious. I'm putting it in the slides for everybody who's sort of paying attention to the slides. And this is our little lookup technique. We're actually covering this in Comp 130 right now in the beginning class, just this idea of, hey, I can drop something else inside of there and have that figure out what the number is. Okay. So, but that's a really slick way to actually wire this thing up. And you're going to be looping through the pieces, right? I is what we're looping through, right? We're not going across rows and columns. We're going through the pieces and then hooking up the grid, okay? So I'll leave that for you to think about a little bit, unless anybody has any questions on that before I move on. But that's some cool little code, right? So we're copying a pointer from there over into the grid so that they're both pointing to the same token piece, okay? So there's an example of that, okay? So, and those are the big hints for this one. Definitely save load grid until you've done your constructor, okay? So let's take a look at a couple syntax reminders and then we'll jump into our just practice stuff for today. So when I say puzzle star, puzzle PTR, that's a variable that has not been initialized officially, and it's going to be a 64-bit pointer. So that thing is 64 bits wide, and eventually it's going to point to something that is a puzzle instance, but we haven't created it yet. Now we're creating the instance of the puzzle. And remember, new always gives us a pointer. So if this creates a puzzle, new is a pointer to that puzzle. And see, they match. Puzzle star, puzzle star. Okay, so everything is happy there. New gives us a pointer to a puzzle. That's a pointer to a puzzle. Apples and apples. And then later on, if I want to delete what puzzle points to, right? I'm not deleting the puzzle variable. I'm deleting what it's pointing to. That's what delete will do for me, okay? And this right here is a pointer. So if I say grid row 0, column 1, it's going to give me the pointer to the token that I need to draw at that location, okay? So I can say grid 0, 1, arrow, and then whatever one of the data members are of the token to draw that token, okay? So grid 01 just gets me the pointer to the token, and then I can reach inside and maybe pull out one of its data members. There's our 25th token, right? That's a pointer from the pieces. So our puzzle box, we pull out all the pieces. If I were to go to position 24, that's the 25th puzzle piece that I pulled out of the box, okay? In the order that I pulled it out, okay? Here's me checking what letter the 17th puzzle piece has. So because pieces holds pointers to a token, we use the arrow symbol to reach into that token and pull out one of its data members. So if we go back and look at the token class, we'll see that it has, of course, a letter data member, okay? Same for the row, same for the column. So we can always reach in to any one of those token things and pull it out. And there's a little logic test. After everything's set up, this should be the same pointer as this. Always, always, always. Because if we wired it up correctly, the 25th row, 25th column should be the same pointer as that, okay? Let you guys sort of soak that up. But that's just a little validity test. If that is not true, then something is wrong with our constructor, okay? Or with our load grid or our constructor, okay? Okay, so it's about a week and a half, kind of coming up on Tuesday. You really only have to implement puzzle.cpp, and I pretty much gave you main, okay? So the big job is really over here. And if you just tack it piece at a time, you should be okay, okay? And it's a good idea to review token, of course, before you take this on. Just make sure you're familiar with that. Okay. Any final questions before we move on to our practice problems for today? Okay. All right. Well, hopefully you have fun with that. I like that one a lot. Okay. So let's just sort of look at what happens with some sample code here in case we haven't got this. So we've got a stack variable that's a num star, it's an int star. So that means it's a 64-bit pointer. Pointer to what? Pointer to integers, right? It's still going to be 64 bits. If you're on a Windows machine, no matter whether it's a pointer to an integer or a pointer to a token or a pointer to a char, it's always, always, always a 64-bit pointer. So you might think, why do I have to say int at all, right? If they're all 64-bit, well, that's just so C++ can keep us out of trouble, okay? So I'll leave it at that for now. But those are always going to be 64 bits. Now I've hooked up a row. A row of what? A row of integers, not integer pointers. There's actual integers in here. They're not initialized yet. They're probably garbage or maybe 0, but probably garbage. Okay. Now here I am saying I'm going to create another one, right? Another row of integers, right? So nums is a pointer to an integer, right? So what I'm really doing here is working backwards and just getting you more comfortable with working with essentially what's going to become a two-dimensional array. So here I'm just reaching into the nums2 and treating it like an array, right? Nums2 is a pointer, but I'm just putting square brackets around and saying, hey, go to the first one, offset by 4 integers, and put a 7 there. So it's like, oh, nums2 points to this box. I'll play hopscotch 4 times, and then I'll put a 7 over there. That's all those square brackets do for us in C++. They are an offset by the data type of some number of addresses. So if it's an integer, we hop one integer. If it's a character, we hop the size of one character. But that's all the square brackets are doing for us, okay? So now if we wanted to, we could build our row structure around this. So even though I've represented this sort of differently on the screen, this is the same as we were just seeing with our grid in our homework 5. We said, hey, I'm just going to hook up U pointer, like whatever U pointer is, I'm going to copy you into myself over here. So if I back that up, you can kind of watch that again. So when I copy that into there, we are now both pointing to the same thing, grid square bracket 0 and nums of 0, grid square bracket 1 and num1, okay, etc. So now grid is a fully functioning two-dimensional structure, okay? And that's really what a two-dimensional array is, okay? It's just that if we want to build it dynamically, we kind of got to go through something like this, okay? And of course, we could just, put this stuff down here instead of having gone through all those extra variable names, but that's how we do it. And now we can just treat it like a regular two-dimensional array, right? Iterate across the rows, right? So if row is 0, I think you all get this, but just in case. So when r is equal to 0, the first set of square brackets gets me here, right? That's that. And then remember that the inner loop goes faster than the outer loop. So that means the inner loop is taking us across the columns. So that's why we consider this to be the row, and these are the columns, okay? Or I go to row square bracket 1, and now I'm going across these, or row square bracket 2, and now I'm going across these. So that's just our two-dimensional structure around our dynamically allocated two-dimensional array. Okay. Yes.
So, clarifying the grid, is it pointing to the array or is it pointing to the num0? So if you were to delete num0, would it still be pointing to something or would it be kind of broken?
So the grid itself is pointing to this chunk of data here. And then when we say square bracket of 0 holds on to num0. So if I deleted this, right, then this access path would be corrupted, right? Because it wouldn't take us anywhere. We'd probably crash. But these are still okay. Like this one's okay and this one's okay. Yeah. So yeah, good question, because deleting this would be catastrophic, right? That would delete all of this stuff and I would never be able to get over here again. But if I, for whatever reason, just say, well, I don't want that row anymore, I would then really need to set that to null, right? Which would be okay. Be like, oh, if that's null, then I won't follow it, kind of thing, right? So, but normally once we build the two-dimensional structure, we just sort of leave it in place, okay? So we can kind of go in and do all that other good stuff. So yeah, we don't normally visualize two-dimensional arrays this way, but if we have to develop them dynamically, like with our homework 5, that's really what's going on underneath the surface, okay? Which is kind of crazy. The rows are just pointing to other areas. So let's just take a look at this slightly different. So here, so notice here we were putting integers in there. So this is an important step up. It's kind of like our practice 3 from yesterday. So we're saying, hey, now I want an instance of 5 tokens, okay? So these are actual token instances, and I need to have a default constructor in my token class for that to work, or it just won't work. You'll get a compiler error, right? Because it doesn't know how to create these unless it has a default constructor. So by default, whatever your default constructor puts in that token, that's what you're going to get in all 5 of those positions, okay? So now I have a row of tokens, and I can create another row of tokens. But of course, the thing that we're holding on to it with is a pointer to the first position of the array. So that's why it's a token star, right? Token star, token star, token star. There's another row. And now we can hook those up by creating our little armature down there, which must be pointers to tokens, right? 3 token pointers, okay? So grid is pointing to that little connector, which we can then hook up to all of these individual rows, right? And now, similar to the last one, but now we have the ability to go in there and copy over the top of it with an entire instance of a token if we want to. Or we could reach into the existing tokens and change one of their attributes or their properties or data members. So there's kind of 2 ways to initialize these. I could either override it with a brand new token, or I could reach inside, say grid RC dot letter equals something, right? Or whatever that token thing has. But here I'm just taking a slightly different path. I'm overriding the entire thing with a brand new token instance, okay? But again, I could have said grid RC dot letter equals something, right? And reached inside of the box and modified just a piece of that token, right? That would have been fine. Equals, X or whatever, okay? So that's an important insight, that you can copy over the top of an entire instance with another instance. That's okay, okay? So that's our kind of 2D structure of array. So we'll just take that up one more notch and then we'll kind of try to move on. So here we're saying, oh, let's just, hang some integers off of there. And this is getting to be more and more like homework 5, right? So here we're going to go through, and although I did one of these manually, I said, go to row 4 and sorry, I said go to nums, this row here rather, position 4 and hook up a brand new integer pointer there, okay? And then finally we work with our, triple star grid, right? Hook up all the rows and then go through and override it with a new integer or something like that, right? So, or not override it, but hook up pointers to all those things, okay? So I know this is probably overkill, but I just, want to show it to you 5 different ways so you kind of get a sense of it. So let's see if we can actually do this one together. So let's allocate a 2D array, in this case, of token instances. So our literal instances are going to be inside of the array. Not exactly like homework 5, but pretty darn close. So let's go in and look at the code together. You guys can follow along or do this yourself. I'll just try to do it without blowing things up, right? So let's take a look. We've got our token class. It's only got a letter, so we've got a simplified version of a token here. And it does have a default constructor. That's a good thing, okay? So we're going to ask our user how many rows, how many columns, okay? And we've got some default values. We're going to overwrite that. So a double pointer, okay? So double pointer because we're going to put instances of the class directly in the array. So our grid is going to be a new something. New what? Token, star. How many of these things? How many rows? Row count. Okay. So I need the row, that little armature, to be a bunch of pointers. And then as I loop through every one of those pointers, I'm going to say that should be a new token. And you basically subtract a pointer every time, right? So now how many columns do we need? This should be column count, okay? UT, okay? No star in there, okay? So that's an actual array constructing the token instance right there, okay? So now I have my two-dimensional array of instances. And if I want to modify something to put a Q in there, I could say, you know, create a transient token instance and call its, constructor and pass it a Q, right? That's not a Q, that's a Q, right? That's one way to override it, okay? And then later on, if I just want to, you know, have something special, so this is going to initialize everything to a Q, but let's say I wanted one of these to be an X, right? I could say, okay, well, I'm going to go to grid position 0, 0 and make that an X, right? Make sure I don't have an extra parenthesis there. Oh my goodness, come on. Shift X, okay, like so, okay? Now, if I want to print out the data member at a particular row column location, let's just do a reality check on this, right? So I'm going to say grid RC, right? But that is what? Is that a pointer or is that an instance? Think about that for a second while I manage to type, right? Should be an instance, which means dot letter, okay? I'll add a little space after, okay? So if that is an instance in the grid, then we use a dot. If it was a pointer, we'd use an arrow, okay? So let's see if I got lucky. And I want to say I would like 10 by 20, okay? So there's my Q with my X up in the corner up there, okay? I got lucky that time. Now I haven't deleted anything, so we've allowed memory to kind of leak over here. So we're going to be tackling that problem here in just a second, okay? I want to make sure everybody's comfortable with this. And for those of you who want to try it, you could also say gridrc.letter equals Q this way, right? So you can just reach in the box, so to speak, and put a Q directly into that thing, and that should work too, okay? 20 by 13. Okay, here we go. Okay, a little tedious to do, but once you do it, now we have this cool structure and we didn't have to know ahead of time how big it was. Now it's still a little different than homework 5 because we're literally putting instances of our token in the grid in this case, okay? So this is what we just did here in case you're curious, right? And note that this right here is where the token gets created. An array of tokens get called, the constructor gets called over and over and over again, column count times for a single row, but we don't call the constructor over here. That's just an array of pointers, which does not call the constructor. Hopefully that kind of sinks in and makes some sense there, Because you might think, well, it says token, so it must be calling the constructor, but it's just saying I need an array of pointers. What kind of pointers? Token pointers. Okay. Okay. Now we got to clean up our mess. So how are we going to actually do that? So here's our two-dimensional array with my silly poor little elephant. So we got to delete the elephants before we can delete the ladder. Okay, that's my silly analogy. So we already did this. We built this thing before. So just as a reminder, if we want to delete this thing, we got to go through and delete the array of instances. So how do I know that this is an array? Well, if I look at each of these things that are the rows, they were created with square brackets. So I got to delete, in this case, 5 integers, right? So delete square bracket grid R as R goes from 0, 1, and 2, right? So we get rid of that, we get rid of that, we get rid of that. And then the moral of the story is you get rid of that, okay? In reverse order. Now notice, of course, that's not inside the loop, but it does have the square brackets, right? Because we create it with the square brackets up here, okay? And we probably should nullify those variables if they are actually in our code, right? So nobody trips over them, okay? Okay, so that is us kind of doing the destructor, but we haven't really put it in the destructor yet, okay? And if we had instances of tokens, it would really be the same code, right? It's just me going through after I create it, delete the rows, then delete the structure that accesses the rows, okay? Which is what the grid is pointing to. The grid variable doesn't go away. That's not what we're doing there. We're just getting rid of what the grid points to, and then we nullify the pointers, okay? Okay, so pretty similar stuff. One last representation of it. This is all a little insane, I realize, but just showing you all the different variations. So I did something silly here and just hooked up integers, right? I put a new integer hanging off of every pointer. This is like homework 5, right? So now I go through and I want to delete individually the integers, right? Okay, so notice that's in that inner loop, right? I'm deleting the integers. Then I have to delete the row, which is an array. Okay, that's still inside of the outer for loop. So I'm going to do that for everything. And finally, I delete what the grid points to and nullify. Okay, so that's pretty much what you got to do in homework 5 for your destructor. Okay. So hopefully that all makes sense. You can kind of go back and look at the video of that, but I'll just show you that one more time. Like if I got stuff hanging off of the tree here, I got to delete the decorations on the tree, and then I can delete the branch. Delete the decorations, delete the branch, delete the decorations, delete the branch, then delete the whole tree. Okay. Or whatever, visual analogy works for you. Yes.
Could you clarify what the first square bracket mean? Like after delete square bracket grid?
This one here.
Yeah, so I understand.
Yes.
I guess I don't understand why you put square brackets.
Right. That's a fair question because, C++ by all rights should know up here when we created this thing, it's created a new set of with square brackets. So this creates this, right? So the rule in C++ is if you don't give it the square brackets, it's just going to release this one right here. And these would, in theory, be somehow floating around in memory. So we are required, unfortunately, if we created it with square brackets, we have to delete it with square brackets. Otherwise, it's going to essentially corrupt memory in a different way, depending on every compiler, it seems like. So.
Then the delete inside the loop?
Yeah.
Have to do that because we're doing each individual.
Exactly. Yeah. So these were created. So this is really what we're deleting. It's kind of weird that I did these variables to help break it down, but basically this delete here is getting rid of this one, then this one, then this one. And so we have to do the square brackets there too, because we did square brackets up here. Okay. Yeah. Yeah. It's unfortunate that we have to do that. And it's really bad that it's a silent error. If you leave it out, very strange things start happening. It can be tricky to find those bugs. Okay. So, and notice, yeah, if you threw in, even if you threw an extra set of square brackets, you'd be like, well, I'm so confused. I'm just going to put them in everywhere. That will destabilize your code, right? Because it'll be like, oh, you want to delete a whole array, but I only have one thing, right? I only have one thing there, right? So yeah, it's really, you know, if it was created with square brackets, delete it with square brackets, and otherwise, you know, don't. Okay. So slightly tricky stuff. Okay. Okay, it doesn't get much worse than that, right? So let's see if we can do this. We're going to have a 2D array of token instances. Again, it's not exactly like our homework 5, but it's pretty darn close. So let's take a look at the code together. And there's only one more practice problem after this, so we'll get you into the lab pretty quickly. So lecture A, practice 2, delete 2D. Okay, so here's our token, right? Somebody's created all this stuff. So all this stuff is created for us. So we just want to kind of implement that logic that we were seeing. So here's us. There's the print of the whole thing, right? So now let's clean up our mess, right? So for each row, this is our silly little elephant analogy. We're going to delete the entire row. So it's going to be grid square bracket R, okay? All right, like so. Okay, so that deletes the row of instances. And then this is really not necessary. It's just sort of, because we know we're going to delete that in a second, right? But now we can just go get rid of the high level structure. So grid, square bracket, grid, or delete square bracket. Oh, yeah. Back and forth with my Mac and Windows skills. Okay. And that should do it. I don't know why I feel suspicious about it, but let's see. 10 and 20. Okay, here we go. So we do it. And then notice that our token destructors are being triggered, right? And we'll go back and remind ourselves what's going on with our token, right? And then that's for row 0. Now we're seeing the row 1 destructors triggered and the row 2, etc. We won't look through all that stuff. But if we get to the very end, we should eventually see that we're all done with everything, right? So let's go see why that message is being triggered, okay? Here's our destructor for our token. So it's just echoing the fact that it's going away because we triggered it. When we deleted the array of instances, we automatically trigger the destructor, okay? So slightly annoying, but it is very instructional to see, yeah, that's actually occurring. We're actually triggering a destructor every time a token goes away. And so deleting an entire row of tokens is going to trigger that many destructors for those tokens, okay? Okay. So not a lot of code, but definitely some deep insights there. Okay. Okay. All right. So where's the best place to put that stuff? So we want to put it obviously in the destructor. So just quick review for those of you us who forgot, a tilde in front of the class name is the destructor. So anytime we have a new in our constructor, we do a delete in our destructor. If I do a new with square brackets in our constructor, then we need a delete with square brackets in our destructor, okay? So let's take a look at some fictional class foo and tilde foo. And let's remind ourselves of a few things. Now, you guys can come back and click on this recording of me from a few years ago now. But let's take a look at what's going to happen here. I create an instance of the foo class, and it's going to automatically print hello and goodbye. Why is it printing goodbye? Well, when we go out of scope, it triggers automatic destruction of the variable. That's our automatic stack variable going away. And that is going to trigger the destructor. Okay, so that's where the bye message is coming from. When we go out of scope at the end of our program, the last thing that happens is all the destructors for any remaining instances get triggered and that memory gets cleaned up. Okay. So whether we create it with a new or we just created just an instance, like with a regular variable, we're still going to trigger that destructor when it goes out of scope. Not just in main, but in a function or a loop or anything, just like any other variable, okay? So that's one of the benefits of automatic variables, right? They get cleaned up automatically as long as we do a good job in our destructor. Now let's take a look at the other example. So here's our foo class again. No constructor called yet. It's just a pointer. It's not initialized, right? So there's our variable pointing to nothing. We don't even know where it's pointing. It's probably garbage at this point. But now I say f pointer equals new foo. So create a foo instance, give me the pointer. That's our hello. Okay. But we never get a goodbye. When we go out of scope, the pointer goes away, but nobody triggered the destructor. We don't get an automatic delete for our heap allocation. That is our responsibility to do, okay? Those are not automatic. So again, the difference is how we declare it. Here, we're creating it with a new, right? Back over here, there was no new. We just said, give me an instance. So that simple little thing is really insightful. It took me a while to really wrap my head around the difference between those two things. This one's dynamic, the previous one is automatic, okay? One of them triggers the destructor, one of them doesn't. If I wanted to clean this up, I'd have to say delete f pointer. I'd have to put that code right in there, right, to get that to go away, okay? So we technically consider that to be a leak. Even though it's the end of our program, we've still got some leaky memory, okay? So here's us kind of doing it the right way, right? So now we get the high, right? And then when we delete it, we get the bye, okay? And then when we finish the program, f pointer goes out of scope and it goes away too, okay? Notice we never call the destructor. It's not like I'm saying, hey, tilde foo, right? I'm just saying delete what this points to, okay? And that's going to trigger the destructor, okay? Okay. All right. Let's take a look at one more example, and then I think we'll finish up here pretty quick. So some of you might remember our idea of creating a car. So here we're going to create a car where the wheels are pointed to by an array. So we're going to have 4 wheels, and we're going to have an array of pointers to those wheels. And we're going to do all that in our constructor, which means our destructor has to walk through the array and delete this, right? And then do that. So it's that reverse process that we saw with our silly elephant example. So here is our wheel. It's just got a little documentation in the constructor and in the destructor so we can see what's going on. Here's our car. So there's our number of wheels. A double pointer. An array is a pointer to whatever it holds. So it's a pointer to wheels, okay? So there's our constructor, right? And here's me hooking up a new wheel to every pointer. So now my car has an array of 4 or how many wheels, and then each pointer gets a wheel. That's our constructor, and we are going to now write the destructor for that together, okay? So let's actually get rid of that stuff, okay? And so remember, this is an array of pointers, not an array of wheels, right? So we're not constructing any wheels here. We're constructing the wheels here. Okay. So let's see if we can do that one. In main, all we're going to do is say, create a car with 6 wheels, and then delete the car. And we want that to trigger all of the other destructors of all of the other parts of the car. So imagine we really were making a very elaborate video game version of a car, or maybe a mechanical simulation of a car for collision, right? And it had 1,000 different instances. We want this one delete to trigger all of those destructors of all of the parts that are part of the car. So that would be a really well-written destructor. For us, we're just going to do it with our wheels, okay? So let's take a look at that real quick. And it's kind of a beautiful thing when you see something like that dismantling itself, automatically and cleaning up all the memory. That's pretty cool. Hold on, we can do it. I know we can get there. Get us out of here. Come on. There we go. Okay, so there's our wheel. It's just documenting what's going on. We've got our constructor. It's already written for us, right? It's creating our new wheels. So let's go down to our destructor. And this is pretty similar to your homework, right? Or it's definitely taking you in the right direction. So we got to walk through our wheels array. So I'm going to say for int x, I'll use w, equals 0. Oops, equals 0. Continue while w is less than, what's our counter here? Num wheels. Okay, while it's less than num wheels. Num wheels, w plus plus. Okay, and then we'll have our curly braces here. So, and then we need to say delete. Wheel pointers, is that what we call it? Wheel pointers array, and that'll be W for us here. Okay. Wheel pointers array W. Okay. So we're deleting a wheel. Okay. Right. So we're saying delete what this points to. That's a wheel. And then the last thing we do is delete the whole framework, right? So we're going to just say delete square brackets wheel pointer array, right? And here's our wheel pointer array. Copy, bring that down here, semicolon, okay? So that's a proper destructor. Get rid of the elephants, then get rid of the ladder, okay? Right, and I think main is already written for us. So let's just see if I got lucky here. There we go. So notice the car constructor constructs, the car destructor starts happening, right? But we don't see it finish until all of the wheels have been destructed. So we're automatically triggering that thing in a nice chain of events. And if I don't call this thing, I never see the wheel destruction. See? So I have to actively say, get rid of the car, and the car gets rid of the wheels, okay? Or maybe the wheels get rid of the bolts, right? So that could go on and on and on in a very deep nested fashion, okay? So everybody who is assigned to develop a class for, let's say, some company, they're going to be asked to do a fully featured class, all of the destructors, everything really nice, and it all works in concert if we kind of write that code in a debugged way, okay? So let's just point out one thing. Let's see if this, what happens if I forget to, did I forget to delete that? Oh yeah, what happens if I forget to do this? Let's see what happens, right? Let me go back to main. Did I leave that in there? Where's main? Oh, it's down below. There we go. So let's see if we get a crash on that one. No, actually, we managed to do it, but that's a very dangerous thing to do, right? So we forgot to delete with square brackets here, right? So if we were writing a bigger program, we could have some destabilized code. So we got to be careful of that, okay? Okay, so I think that's our last one, okay? So little test question for you before we go, though. I got two instances of the car here. And if I use just this code right here inside of this local scope, which of these cars is going to have its destructor triggered. In other words, which car is going to get cleaned up, okay? So I have an automatic allocation, or this is a pointer to a new car, and then I have an automatic allocation, my car over here, with 2 wheels, okay? So the big clue is you don't see the word delete there, right? So the only one that's going to really get cleaned up is going to be the automatic one, right? So the automatic stack variables are going to go away, including car PTR, but not the dynamic memory that's hanging off of car PTR. Okay. So if that's a surprise, that's okay. But yeah, think about that one, right? We never actually told it to delete the car, so it didn't do it. But car PTR goes away, and now we've got a leak, and we really can't get back to it and clean it up, okay? So we could go crazy with this stuff, right? We can have, a car comprised of all sorts of stuff. I won't take you through this other one because I think we've seen this before. But somebody, in this case, notice you might think, oh, I have to delete these wheels. Who's going to delete these wheels, right? Well, there's no new in our constructor. If there's not a new in the constructor, there's no delete needed in our destructor. So you might think, well, who's going to get rid of that? That's an automatic variable. So C++ is going to get rid of the data members for us. But if we had new in our constructor, then we would need to do some delete down here. But since we don't have new, that's not anything we really need to worry about, okay? So here's us creating a new car and deleting the car. That's okay. That works. And we saw that kind of in our last example. Okay. And there's us constructing, and then it's automatically going to go out of scope and destruct. Okay. Okay. So fun with cars and car parts. Okay. So keep in mind, if you exit the function. So sometimes I see people do this. They decide they want to quit their program, and so they say, well, I'm just going to exit. But exit bypasses all kinds of destructors. So it's a very volatile way to leave a program. We don't really want to exit a program like that because there might be file pointers left open. There could be all sorts of things we haven't cleaned up. So it's better to just exit normally without by getting to the end of main rather than forcibly jumping out of there, okay? And I think probably this I've said, but oh yeah, here's an interesting one. Sorry to drag this out, but so if I delete what PTR points to, and then I use PTR again, right? I just create some new memory, or somebody else creates some new memory. My PTR is still pointing to that same thing. It could be that we'll see a 10, or we might see some garbage there, right? So just because we delete PTR doesn't mean that the memory is no longer being used. So we got to be careful to reset our pointers so that we don't accidentally use them after stuff's deleted. So don't forget about your Quizlets. You can join the class if you want, but it's not required. But there will be a lot of useful stuff in there. So all you got to do for Lab 18 is write the destructor for the code we had last night. And so Lab 18 has everything written for you. So all you got to do is click into it and go find where your destructor code should go, and just make sure you kind of don't crash your program. So I'll just show you where that is real quick, and I'll let you guys get on with it. But basically, here's our constructor here, right? And you can fold that up if you like. And our destructor is down here, right? So you have to write your code right in here, okay? And I put this message done in there so that you know whether you're crashing or not, okay? And notice that we're going to create a million instances of the try matrix. So if you have even one character out of place, your program is going to crash because it's going to run out of memory, right? So if you're doing it correctly, we create a pointer, we allocate a matrix with some number of rows, and then we delete that matrix. So that should be a zero-sum game. But if you have a leak, that information is going to just grow and grow and grow in memory until your program crashes. Okay. So that's kind of just an explanation of what's going on in main there. So you don't have to write main, you just got to get your destructor working properly and you should be okay. Okay. So we're going to wait, we're going to create a loop, and then we're going to wait again until you enter some value, right? So notice this is just my sneaky way of creating a pause for your function. I have an integer and I wait for you to type a number, right? And as soon as you do, we start going. And then I wait for you to type a number again, and then we say goodbye, okay? Now, if you're using Replit, you can kind of watch your RAM usage go up, but don't worry about that. I think you'll know pretty quickly if your program works correctly, whether or not you've used your memory, okay? So there's your stuff, right? Remember, our structure of things looks kind of like that. And you're going to do it in that order, okay? I think that's it. Yep, that's it. Okay, thanks everybody. Let you go, and I'll see you on Tuesday. Send me an email if you get stuck on homework 4. Okay, thank you. Thank you. Have a good weekend.